Good day, my name is Padilla John Michael and I am here to discuss SCR phase control. So SCR phase control is basically the manipulation of circuit elements or components in order to achieve a certain firing angle, and firing angle is the delay in the graph in which the SCR is said to turn on. So here in the circuit wizard file, we have a simple SCR circuit. So at the anode, we have a load resistor connected and the cathode is connected to the ground, and on the gate terminal we have a potentiometer, a diode, and a capacitor. So here, first the diode. So the function of the diode here is to make sure that only positive signals will be going inside our gate terminal, and the potentiometer is the component that somehow provides biasing voltage for our SCR. It helps trigger our SCR, and the capacitor here is actually a delaying component. So this capacitor will help us achieve a firing angle which is greater than 90 degrees, because on a purely resistive circuit, the maximum firing angle that can be achieved is 90 degrees. So going to the simulation, so with our potentiometer at 100%, we can see that there is almost no firing angle that can be seen in the graph. However, if we decrease that, we can see that the firing angle is slowly increasing. There. If we decrease it more, let's say up to 63% or 62, we can see that we already achieved the 90-degree firing angle. So if we decrease the potentiometer more, since we have a capacitor, we can increase the firing angle greater than 90 degrees. So as we decrease it, as you can see, the firing angle is increasing. So looking at the graph, this is already a firing angle that is greater than 90 degrees. So that is how you initiate phase control on an SCR circuit. So for this part of the video, I will be discussing and I will also be giving an example regarding relay circuits and ladder diagrams. So before we go into that, let us first discuss what is a relay circuit and what is a ladder diagram. So a relay circuit is actually known to be a device that can handle very large loads. So what happens in a relay circuit is that in a relay circuit we have a coil. So this coil is actually associated to different contact switches that can be found in the relay circuit. So what happens is that, for example, when the coil is being energized or when voltage is applied, what happens is that the contact switches associated to that coil changes state. So for example here, so we have a coil here and we have a contact switch, and this contact switch is a normally open contact switch. So what is expected to happen is that when we energize this coil, this contact switch must change state. So to test that, we can see that if we press this push button, so since the coil is being energized, we can see that the contact switch changed its state and it is now a normally closed contact switch. So that is what happens on a relay circuit. So moving on is to the ladder diagram. So a ladder diagram is actually a way of presenting the relay circuit. So it is called a ladder diagram because it looks like a ladder when constructed. So in the side part of this diagram, of this ladder diagram, are the voltage supply. So we have the 24 volt supply and 0 volt supply. Next, for the horizontal part, or which looks like the steps of a ladder, we call this the rung of a ladder diagram. So this part contains the switches, the relays, and the contact switches. Now moving on to the examples, we have here a normal OR circuit. So recalling the truth table of an OR circuit, so in order to have an output of true, one of the outputs must be true. So in this circuit, in applying the concept of that truth table, so in order to turn this lamp on, we must at least push one of the buttons, or we can push two of the buttons. So that is the function of a OR circuit. So we can test that by simulating the circuit. So by pressing the first switch, we can see that the lamp is turned on. So here, the lamp is turned on. And if we push the second switch, the lamp also turns on. So we can see that as long as one of the inputs are turned on, or as long as one of the switches are pushed, the lamp turns on. Now let's try two of the switches. So we can see that the lamp is still on after pushing two of the switches, which means that we were able to create a circuit that precisely resembles the function of an OR circuit. So that is it for relay circuits and ladder diagrams. So in this part of the video, I will be discussing, and I will also be giving some examples regarding relay latching circuits. So first of all, what is a relay latching circuit? So as seen here in the diagram, a relay latching circuit is also a ladder diagram. It can be constructed using a ladder diagram. However, what makes it special or distinct is that a relay circuit, even though the satisfying condition was already removed, the outputs will still stay the same. So to have a better understanding on that, let us simulate this circuit. So looking at this circuit, we have our coil and our two contact switches. So the expected output here is that once we press the push button, the two lights should turn on, and after we release the push button, the two lights should still be on for us to say that it is a relay latching circuit, since pushing the push button is the satisfying condition for the lamps or the lights to turn on. So to simulate the circuit, so if we push this push button, we can see that the coil is energized, and at the same time the two lamps are turned on. And if we release that, the two lamps are still on and the coil is still energized. So with this property of the circuit, we can say that the circuit is a relay latching circuit. So that would be all for relay latching circuits.